You may be familiar with how relational databases organize data into tables of rows and columns. At first blush, Cassandra appears to organize data in much the same manner. However, there are some nuances to Cassandra storage organization, which we will explain in this scenario. Cassandra uses a set of one or more machines to store and process data. We call this set of machines a cluster. Clusters contain databases, which Cassandra refers to as keyspaces. Keyspaces contain tables, and tables logically contain rows and columns. Notice that I said tables logically contain rows and columns. Actually, Cassandra tables contain partitions, and partitions contain rows and columns. The secret to Cassandra lies in understanding this novel construct known as a partition. Each row in a Cassandra table has a primary key, which is one or more columns that uniquely identify the row. Within the primary key, at least one of the columns is designated as the partition key, so a partition key is part of a primary key. There may be more columns in the primary key that are not part of the partition key. These additional columns are called clustering columns. Within a table, Cassandra stores all rows that share the same partition key in the same partition. Or in other words, a partition is a set of one or more rows with the same partition key. When Cassandra retrieves a partition, Cassandra hashes the partition key and uses the result to locate the partition within the cluster. As you may recall from your computer science studies, hashing is fast, so finding and retrieving a partition is very fast. This partitioning organization has some implications. First, Cassandra requires, at least, the entire partition key to be able to satisfy a query. Second, Cassandra generally retrieves all the rows for a partition at once. So if you want your queries to be fast, you should store the results for a query in a single partition. It's kind of like partitions are pre-computed query results. Third, you can also use clustering columns in your query's where clause to filter the partition results. Clustering columns serve two common purposes. First, Cassandra orders the rows within a partition based on the clustering column values. This is good to know because Cassandra will return query results in clustering column order, which means you can use clustering columns to order your results. Second, you can use clustering columns to make a primary key value for a row unique. This scenario will show you some examples to make these concepts more concrete.